Welcome. This question says, for equal positive charges, lay at the points indicated in the diagram. And equilateral triangles, 2 by 2 by 2. The magnitude of the force experienced by charge X because of charge Y, so we're looking at these two down here, is 3 newtons. So they're all equal size, and it's telling you the force that results when one charge is 2 meters away from the other. And then what is the magnitude and direction of the force experienced by charge Z? So let's redraw this. And the focus is going to be on charge Z, so on this guy here. And we can take each of these pairs of charges independently. So X acting on Z will cause a force, and Y acting on Z will cause a force, and W acting on Z will cause a force. And because they're all the same charge and they're all 2 meters away from each other, this 3 newtons applies here, and this charge here causes a force of 3 newtons in that direction, and this charge here causes a force of 3 newtons on this charge in that direction. So a few tricks there, wasn't there? Let's highlight some of these. So it told you the force caused by these two, so you could apply it over here. And it also, you had to recognize the fact that, oh look, that's 2 meters, that's 2 meters, that's 2 meters, that's 2 meters. So if this is 2 meters and there's the force you get, this is 2 meters and there's your force you get, this is 2 meters and this is 2 meters. So there's an awful lot of symmetries in this that aren't stated explicitly, but are there to be seen. It asks for what is the magnitude and direction of the force experienced by charge Z. Well, we have 3 forces acting on charge Z. So let's resolve these forces. Let's break this charge up into a vertical component and a horizontal component. And let's take this other force down here and break it up into a vertical component and a horizontal component. And then I see something that's very nice, and that is that this vertical component will be the same size as that vertical component, but they will be in opposite directions because of symmetry, and so they will cancel each other out. And so I'm left with 3 forces. I'm left with the original force caused by X and Z. I'm left with the X component of the force caused by W on Z. And I'm left with the X component of the force caused by Y on Z. So it's these 3 forces down here that I'm left with. And, well, this is equilateral, and all those guys are 60. So that means this is 60, and that means this is 60. So this guy, using my trig, would be 3 cosine 60 degrees. And this guy would be 3 cosine 60 degrees. Let's put newtons down so we know we're talking about forces. So let's have a look. So my force on Z is equal to 3 plus 3 cosine 60 plus 3 cosine 60, which equals 3 plus 1.5 plus 1.5. So my force on Z will equal, let's have a look, that should be 6 newtons, and it's going to be horizontally to the right. So there's my overall answer. It tends to be, if there are favourite questions in the physics world, it tends to be one that I remember getting as an undergraduate, and I've seen it on various people's exams throughout my career. And I think the reason is that it involves going back and using some trig and using some symmetries, and of course, the underpinning theory is the superposition theory. The idea that if I know the force caused by one pair of forces, I can add another force and I'll get another independent force. I can add a fourth charge, and I will get another independent force. And these guys can just be added vectorially. To some extent, what people sometimes think is that if I have two charges causing a force, if I bring a third charge close by, it somehow detracts from the first force, because somehow, I don't know, maybe the attention of the charge at Z is distracted from the charge at X. I'm not sure why. But the fact is that the effect of W on Z is completely in addition to the effect of charge X on charge Z. And if I bring a charge Y up there, the effect of charge Y on Z is completely in addition to the previous two forces. So it's the superposition theorem, and that's what this question's about. So there we have it.